Welcome students. We are still continuing with the discussion on the types of materials we have, and we are exhausting the types of ions we have. So today I will walk you through cast iron. Cast iron is gray in color, which is due to the carbon being principally in the form of graphite. It contains carbon of percentage of 2.5 to 3.8% and silicon of 1.1 to 2.8%, manganese of 0.4 to 1%, and phosphorus is less than 0.15%, sulfur less than 0.1%, and the remaining composition is that of the iron. So what are the outstanding properties that make this kind of material useful in engineering field or generally in the universe? One property is that when fractured it gives a gray color. So this is how we can remarkably identify it from other types of materials. It can be easily casted, that is, during the casting process, when you heat it and it becomes liquidy, it can flow. It has fluidity value so that it flows to form the new shape that you intend for it to cool into. It is marked by the presence of flakes of graphite in a matrix of ferrite and pearlite or austenite. It can be easily machined and possess machinability better than steel. So this makes it very useful in most of the engineering applications, because we need to machine it to make other components like bolts, nuts, etc. It possesses lowest melting or ferrous alloys. It possesses high vibration damping capacity, so we can use it as a damping material. It has high resistance to wear. It possesses high fluidity and hence can be cast into complex shapes and thin sections. It possesses high compressive strength. It has a low tensile strength. It has very low ductility and low impact as compared with steel. So the fact that it's less ductile and low strength is not suitable for some of the engineering applications where strength and ductility is a factor. So where can we use this type of cast iron? It's normally used in machine tool structures for making machine beds, frames, and columns. Used in household appliances. Used for gas and water pipes for underground purposes. Used for manhole covers. Used for making piston rings, rolling mills and general machinery parts, cylinder blocks, and heads of ignition compression engines, frames of electric motor, ignite mold, and general machinery parts, sanitary wares, tunnel segments. So another type of cast iron is white cast iron. It is white in color due to the fact that the carbon is in the combined form of carbon, that is the carbide state, which is also known as the cementite. It is hardest because of the constituents of the iron and the carbide element in it. It is produced in a cupola furnace by refining or pig iron. The white cast iron may be produced by casting against metal chills or by regulating analysis. The chills are used when a hard and wear resistant surface is desired for products such as for wheels, rolls, crushing jaw, crusher plates. The chemical composition of white cast iron is as given. So it has 3.2 to 3.6% of carbon, 0.4 to 1.1% of silicon, 0.1 to 0.4% of manganese, and 0.3% less of that phosphorus and 0.2 of sulfur. The remaining composition mix is the iron. So properties, its name is due to the fact that its freshly broken surface shows a brittle white fracture. It is a very hard due to carbon chemically bonded with iron as iron carbide, which is brittle also. It possesses excellent abrasive wear resistance since it is extremely hard, therefore it is very difficult to machine. Its solidification range is 2650 to 2065 degrees Fahrenheit. Shrinkage is 1/8 inch per foot. The white cast iron has high tensile strength and a low compressive strength. Applications: we can use it for producing malleable iron castings, for manufacturing those components of or parts which require hard and abrasive resistance surface such as rim of the car, railway brakes block. Let's discuss the next type of the cast iron, and that's ductile cast iron, which exists, which has small quantities of magnesium or cerium, which is added to the cast iron to make the ductile cast iron. Then graphite content is converted into nodular or spheroidal form, and it is very dispersed throughout the material. The resulting structure possesses properties more like cast iron than like the other grades of the cast iron. A typical structure of spheroidal cast iron is shown in figure 4.2, and I will just show you that. This is the structure, and the graphite is in spheroidal form instead of in flaky form. So you can see the spheroidal form instead of these flaky forms. The composition of this ductile cast iron, it has 3.2 to 4.2% of carbon, 1 to 4% of silicon, 0.1 to 0.8% of manganese, 0 to 3.5% of nickel, and 0.5 to 0.1 of magnesium, and the remaining one is iron. So silicon is also used as an alloying element since it has no effect on size and distribution of carbon content. The magnesium controls the formation of the graphite, but it has little influence of the matrix structure. Dear students, this marks the end of our today's lesson. Thank you for listening and also watching this. We will meet next in our next